Arithmetic sequence. Arithmetic sequence is a sequence in which the constant term d is added to get the next term. The constant d is called the common difference. To find the common difference, we can subtract any two consecutive terms like a2 minus a1 or a3 minus a2 or a4 minus a3. So a1, a2, a3, a4, a5, all these are the terms of arithmetic sequence because we keep on adding a 3 each time we get the next term. We could be adding a positive or a negative number as we go to the next terms. Domain of arithmetic sequence is the natural numbers. So explicitly defined sequence is an equals 3 plus n minus 1 times d. Recursively defined sequence is where we are defining a sequence using the previous terms. Examples. So here we want to find the first term and the common difference for each of the arithmetic sequence. We can clearly see the first term a1 is 4 and the common difference d is going to be second term minus the first term. So that's 9 minus 4. 9 minus 4, the common difference d will be 5. In the second example, the first term a1 is 34 and the common difference d here is difference in any two terms, which is 27 minus 34, and that would be 27 minus 34 would be 7. So that's negative 7. The common difference d is negative 7 in this case, and first term is 34. So we can subtract any two consecutive terms to find the common difference. A2 minus A1, A3 minus A2, A4 minus A2, any two consecutive terms. Always be careful and check that all the common difference is the same between each term, because it's possible that a sequence might look like arithmetic and in reality might not be. So check the common difference between each two terms that you are in reality adding or subtracting the same number as you go to the next term, as you get your next term. Go ahead and give it a try. Pause for a minute. Find the first term and the common difference. Find A and D for both of these problems, A and B. And come back and check. For first problem, the A is 1 and the common difference D is negative 5, because going A2 minus A1 would be negative 1 minus 4 is negative 5. Second one, we have A1 as 11. A3 minus A2 will be 11 minus 23 minus 11, which is my common difference. D is 12. Right, next. First term of an arithmetic sequence is A or A1, however you want to express it. We add D to get the next term, so there's a pattern. The first term, A1, is just A1. Second term, we add 1D to it. To get the third term, we add 2Ds to it. To get the fourth term, we add 3Ds to it. So the pattern is, to get the nth term, we will be adding an would be equal to a1 plus n minus 1 times d. We'll be adding one less of a d than the term we're looking at. So if I'm looking at the second term, I'm adding 1d in here. Third term, I'm adding 2d's. Fourth term, I'm adding 3d's in there. Right, so first term of an arithmetic sequence. So here's a formula. This is called the nth term formula for arithmetic sequence. An equals a1 plus n minus 1 times d. An equals a1 plus n minus 1 times d. An is the last term in the sequence. A1 is the first term, and n is the nth term that we are looking for, and d is the common difference. Here's an example. We want to find the 14th term of this sequence. Well, you might say, hey, I can just keep on adding or subtracting the same number and get to the 14th term. But think about, what if they wanted you to find the 100th term? You don't want to write 100 terms and then find the 100th term. We want to use the nth term formula. The nth term formula is a1 plus n minus 1 times d. Okay, so an equals a1 plus n minus times d. In this case, a1 is 4 and d, the common difference, is 7 minus 4, which is 3. So to write the 14th term, we want the 14th term, that would be A1, which is 4, plus n is 14, 14 minus 1 times 3. So 14th term will be 4 plus 13 times 3. 4 plus 13 times 3 is 39. 39 plus 4 is going to be 14th term. So a 14th, or the 14th term in this case, is going to be 43. If I were to find the 100th term, I'm going to use the formula similar way. A 100 is equal to A1. In this case, the first term is 4 plus 100 minus 1 times 3, which is 4 plus 99 times 3. And we can go ahead and simplify it and get the 100th term. So we can use this nth term formula to find any term of this sequence. Next, find the 14th term of arithmetic sequence with the first term 5 and the common difference -6. So we're given the first term is 5, we're given the d is -6, and we want to find the 14th term. Again, nth term formula is an equals a1 plus n minus 1 times d. So we want the 14th term, that would be a1 plus 14 minus 1 times d, and we already know the a1, the first term is 5, and the common difference is -6. 14 minus 1 times -6. So 5 plus 13 times -6, which is 5 minus 13 times 6 is -78, and 5 minus 78 will be our next term, which is -73. -73. Right, so we just found the any given term based on sequence is given, and the second time we were given the first term and the common difference. Now go ahead and try these, find the 10th and 25th term for these three sequences, arithmetic sequences, and come back and check your work on the next page. Right, next example. In the arithmetic sequence, which term has a value of 301? So which term of the sequence is equal to 301? Let's see. Is it 10th term? Is it 20th? Is it 50th? We don't know. But we can use the nth term formula, which is an equals a1 plus n minus 1 times d. So we are looking for n in this case, and we don't know what n is, but we do know that the nth term is 301, and the first term is 4. The common difference in this case is 7 minus 4, which is 3. So that turns out to be 301 equals 4 plus n minus 1 times 3. Right, so 301 equals 4 plus 3n minus 3. 301 equals 7 plus 3n. 301 minus 7, so we're going to subtract 7 from both sides, and we will be able to divide 294 equals 3n. n equals 294 divided by 3, and that's going to be 98th term. So it's going to be 98th term of the sequence. Let's double check my work. A1 is 4 plus n minus 1 times 3, which is going to be, oh no, go back, fix. This is not going to be 7. 4 minus 3 is 1. So that will change my work from here. That's going to be 1 plus 3n. Subtract 1 from both sides. 300 equals 3n. Divide both sides with 3, and we get 300 divided by 3 is n. So n turns out to be 100. So 100th term of this sequence is 301. 100th term of the sequence is 301. Next example, in an arithmetic sequence, 10th term is 33 and 22nd term is -3. What are the first 4 terms of the sequence? So we're given the 10th term and we're given the 22nd term. So for the 10th term, nth term formula, A10 is going to be A1 plus 10 minus 1D. So 10th term is A1 plus 9D. And for 22nd term, the nth term formula will be A22 equals A1 plus 22 minus 1D, which is A1 plus 21D. 822. Now let's go ahead and plug for the 10th term. We can plug 10th term is 33, that's given to us. A1 we don't know, so 33 equals A1 plus 9D. And we also given 22nd term is -3, and we don't know A1 and D. So these are our two equations. That's going to give us a system of equations. So we have two equations in two variables, two missing things, and we can go ahead and solve that system. So let's rewrite them here. This is A1, not a 9 here. A1. -3 equals A1 plus 21D. Let's go ahead and solve this system. It looks like we can easily make the coefficients of A1 equal and get rid of A1 from here. So we're going to multiply the second equation with -1. That will make it a positive here, negative here, and a negative here. 33 plus 3 is going to equal 36, and we will be able to cancel the A1 from here, and we have -21D plus 9D would be -12D. Go ahead and divide both sides with -12, and this is going to give us D equals -3. Once we found the D equal to -3, we can either plug into the first equation or the second equation and simplify from there. So let's go ahead and plug it into the first equation. Plug D equals -3 in 33 equals A1 plus 9D, and we'll be able to solve for A1 here. So 33 equals A1 is my first term. That's what we're looking for. 9 times -3. 33 equals A1 minus 27. Add 27 to both sides. 33 plus 27 is going to give me A1 is equal to 60. So my first term is 60, and we have the common difference. We have the first term. We can write the first four terms of the sequence, which is going to be 60, and the common difference is -3, 54, 51. All right, that was another example of writing an arithmetic sequence where we were given two terms of the sequence. Now pause for a minute, go ahead and try this problem. For arithmetic sequence, 12th term is given and 5th term is given. Find the 20th term. Come back and check. We're given the 12th term and the 5th term. We will have the nth term formulas for both of these, and then we can solve the system of equations, and that gives us the D common difference. D is equal to 1. Actually, 11D minus 4D gives us 7D equal to 14. D comes out to be 2. So if D is 2, we can plug it back into original equation and find out A1 as well. So if D is 2, 32 equals A1 plus 11 times 2. 32 equals A1 plus 22. A1 turns out to be 10. So we found the common difference and the first term. We were given two terms. Another problem for you to try, which term of the arithmetic sequence is 88? And I did not give you the sequence, so I should have given you the sequence. The sequence is 1. Let's go ahead and rewrite it. It's going to be 1, 4, 7, all the way to 88. So to find which term is 88, we would use the nth term formula again. An is equal to A1 and minus 1 times D. So here the D turns out to be 4 minus 1, which is 3 again, and A1 is 1. So we're looking for what's the n, what is the term when nth term is equal to 88. 88 equals A1 plus n minus 1, 3 minus, n minus 1, n is what we're looking for, times D. 88 equals 1 plus 3n minus 3. 88 equals -2 plus 3n. Add 2 to both sides. 90 equals 3n. N turns out to be 30. So 30th term of this sequence is going to be 88. Right, that was all for this video. In the next video, we're gonna talk about partial sum of arithmetic sequence.